R. Prabha, Assistant Professor in the Department of ECE, SNS College of Technology. In this video, we will see about helical antenna in normal mode and also axial mode. And we know the antenna which provides the circular polarization is the helical antenna. And if we see about helical antenna, it is a very directional antenna which provides circularly polarized waves. Some of the antennas only provide circularly polarized waves, and helical antenna is one among those. And the polarization changes with respect to time in helical antenna, and high gain it provides wider bandwidth. And geometry of the helical antenna consists of a ground plane, metallic ground plane, and attached with the feed system, and above the ground plane there is a helical structure, and the wire of helical structure. To support this, there will be a rod in between the turns of helix. The turns of helix may be one turn or more number of turns. And some of the parameters which defines the geometry of helical antenna is: D is the diameter of the helix, C circumference, L naught is length of one turn, alpha is the pitch angle, S is the spacing between the turns, N is number of turns, Lw length of helix, D is the diameter of the conductor. So this is about the geometry. And the helical antenna, the special feature is it can operate in any one of the two modes. One mode is called normal mode and another one is called axial mode. So in normal mode of operation, the helical antenna, the dimensions are very small compared to the wavelength at the frequency of operation. We know that the wavelength of the helical antenna is calculated from the formula lambda is equal to C by F. So all the parameters of the helical antenna is in terms of wavelength, and these dimensions are very small compared to its lambda value, that is the wavelength value. And if we inspect the radiation pattern in normal mode of operation, the radiation pattern is similar to the linear dipole antenna, that is, it provides the bidirectional radiation pattern, and bandwidth is narrow. Radiation efficiency will also be very small. So because of these disadvantages, the normal mode of operation of helix is rarely used. And if you see the next type of mode of operation is the axial mode of operation. So in axial mode of operation, the helical antenna provides circularly polarized waves, and it provides greater efficiency and covers wider bandwidth, and the dimensions of the helical antenna is large when compared to the wavelength at the frequency of operation. And here the lambda by design parameters or design equations can be given as lambda by 4 is equal to C by lambda less than 4 by 3. So the C by lambda ratio between circumference to wavelength value lies between 1 by 4 to 4 by 3. And C by lambda is approximately equal to 1 and near optimum, and the spacing is equal to lambda by 4. Half power beamwidth is 50 cross 50 degrees. So this is the helical antenna in axial mode of operation. And now come to the applications. So applications, space telemetry applications of satellites, space probes and ballistic missiles, this helical antenna is used. And the signals have undergone Faraday's rotation in helical antenna. And this is also useful in directional application because helical antenna provides a beam of very high directivity. And now the assessment question. The special feature of helical antenna, we know that helical antenna consists of it provides circularly polarized waves, electromagnetic waves, and the two modes of helical antenna we know it is discussed in the PPT. It is normal mode of operation and axial mode of operation. In normal mode, helix dimensions are small when compared to the wavelength. In axial mode, the helix dimensions are large compared to the wavelength, and the dimensions equations also we discussed. And application of helical antenna we discussed, as it is a spatial satellite communication application, telemetry applications, and it provides high bandwidth and circularly polarized waves. The helical antenna applications are in high frequency and ultra high frequency, very high frequency ranges, and the helical antenna provides high efficient and it covers large beam width, and it provides unidirectional beam of radiation, that is beam radiation is perpendicular to the helix dimensions, and it is not in the opposite phase. And this is about the helical antenna. Thank you.